Okay. There are going to be a few absentees today, but we'll get started. And someone mentioned they're running late. That's fine too. Excuse me, as long as you guys catch up on the videos later. Okay. All right, you can ignore this from previous class. Able to see my screen, right? Someone confirm. Aditya, you're able to see my screen?
Yes, sir.
Okay, cool. All right. So we had a few questions to discuss in homework 9. And then, okay, then we'll go with some plan I had in mind. So first, let's discuss those few questions. Where is homework 9 now? Thought I had it just now here. Sorry, guys, I'm just searching. I'm just finding. Work 9. Okay, all right, found it. So there are three or so questions we have to discuss. If you all bring up homework 9, what are you seeing on your screen? Are you seeing my homework 9 or are you seeing the whiteboard?
So there's like a gray spot. We can't see the homework.
You should be seeing something, right? Are you able to see?
Well, we can see some gray rectangle.
Gray rectangle. Okay, unsaved document. Now you're seeing this document?
Yeah, now we can see. But
Okay,
it's
okay.
blank.
Okay, yeah, it's blank. I didn't start writing anything. So we discussed question 1, 2, 3, 4, 5 as well. 6 was in the spheres. We'll come to the spheres. Let's do the 7, which is on the semicircles, 8 semicircles. Let me paste the question here. Were you guys able to attempt this one? What did you get, RF? Were you able to do this one? What is the radius of the circle tangent to each of these?
Oh, so just 1 second. I'm just opening up.
Yeah. And Yuvam, I'm not able to see your video. So please turn on your video. I'm not able to see you.
Oh,
That is.
yeah, sorry, I forgot.
Yeah, that's fine.
So what happened to my camera?
No, I cannot see you. I can only see an empty camera. Maybe something you can fix later then. Okay, RF, back to this question 7. Were you able to do this one? Any answer?
Yes, so I got the answer as B, 5 root 5 minus 1 over 2.
Okay. What about you, Veer? Agree with him or disagree with him?
Yeah, so I got the same answer.
Root 5 minus 1 by 2. Okay, all right.
Yes.
Let's discuss quickly. So you have the center of the square is here. He says each semicircle side length of the square is 2. So this entire stretch is 2, which means from here to here is 1. Right? So here to here is 1. Likewise. So if I complete a right triangle, something like this. So always remember, whenever there are circles which are tangent to each other, try to draw a line connecting the two centers. That's the first thing you should do. So I'm trying to connect this center with this center. The advantage of that is you'll end up getting some Pythagoras theorem, and the length of this would be the sum of the two radii. Okay, so the radius for the semicircle, we know is half. Sorry, what happened to this now? Okay, the radius for the semicircle is half, so this is half. Okay, now let's focus on this right angle triangle. This guy and then this guy. Okay, so the hypotenuse is what now? If I look at this length, this is the r that we have to solve for. Okay, so and then this is half. Okay, and then this other line is half of the 2, right? So this length is 1. You agree? So the Pythagoras theorem just is half square plus 1 square equal to the hypotenuse square, which is r plus half the whole square. Okay, I hope this solving this will give the answer. Let's see. So this is 1/4 plus 1 equal to r square plus 2r plus 1/4. So 1/4 gets cancelled. So r square plus 2r minus 1 equal to 0. So r is minus b plus or minus square root of b square minus 4ac. 4 plus 4 whole by 2. Am I doing something wrong, guys? So I'm getting minus 1 plus or minus root 8, which is 2 root 2. So minus 2 plus or minus 2 root 2 by 2, which is minus 1 plus root 2, which is not in one of the choices. So clearly I'm doing something wrong. Can you find some mistake in what I'm doing, guys?
I have a question.
Yeah.
How did you get that length as 1?
Because this entire side length is 2, right? This entire side length is 2.
Oh, okay. So
And
you
therefore this is 1. And then the radius of the circle in the center is what we are trying to calculate. I've kept that as r. And the radius of the semicircle is half. So r plus half whole square equal to half square plus 1/4 square. Do you guys see any mistake in this one? Let me just try. This is not even in one of the choices, right?
So I used Pythagoras theorem as well, but I'm
Go ahead.
not sure if you did. I can just share. It was quite simple, the one
Go
I
ahead.
did.
Go ahead, please. I would still like to understand what mistake I'm doing.
Yes,
But,
yes.
but go ahead with your approach, please.
Okay. Is it fine if I just point some things in the?
Yes, absolutely fine. In fact, should I just copy paste this diagram so that you can do this here? Okay, yeah, please. Can you just try on this one?
So I also drew the triangle to the center, to the two centers.
Okay.
I figured out that this was 1.
Yeah.
This, and then this is 1. This is 0.5 half.
Correct.
Then I figured out the radius. I used Pythagoras theorem to get that side, which I just used 1 square plus half square, which I got to be root 5 over 2, or the
Correct.
entire radius.
Correct.
Of from the center to this center.
Yeah.
Then I just subtracted, since we know this is half.
Correct.
I just subtracted 1/2 from that.
Yes, absolutely. Exactly. That's what I've done. So maybe, okay.
Your expansion went
expansion.
r square plus r.
Exactly. R square plus r. No wonder. Yes, correct. Yes, correct. So if you make this r, thank you guys. Thank you guys for spotting this. So r square plus r instead of 2r. Let's complete this. Yeah, r square plus r, 2 into r into half. And therefore the quadratic just becomes r square plus r minus 1 equal to 0. So minus 1 plus or minus root of 1 plus 4 divided by 2. It cannot be a negative answer. Therefore it's minus 1 plus root 5 by 2, which is exactly the answer that you guys got, right? B was this root 5 minus 1 by 2. Did you say?
Yeah.
Yeah. Okay. And like you said, I don't even need to expand this. I can just do the left-hand side, which is 5 by 4. I can just say root of 5 by 4, which is root 5 by 2, is r plus half. I don't even need a quadratic. And I can just subtract. Yeah, excellent. Well done, and bad on my part of doing this silly mistake. Okay, cool. Thankfully, there's no answer which is my wrong answer. Therefore, I would have checked and found the mistake. But not always you can expect to be lucky. There will be definitely, depending on some few common silly mistakes, the exam setters will plant those answer choices. So we should be very careful. Okay, well done. Question 7 that was. Let's do question 8. Question 8, and this was a little difficult one. Did anyone get question 8, this one? Trying 86 and 97, this one, did anyone get it?
So I didn't get the exact answer, but I think we have to use power of a point for this. I wasn't sure how to proceed.
Okay, cool, well noted. Anyone else? Yuvam, did you get an answer on this?
I didn't get this one.
Okay, Veer, Aditya, how about you?
Nope, didn't get it, unfortunately.
Okay, that's fine. Yeah, it's definitely a more difficult question. Okay, so let's draw a diagram first. So let's say this is 97. Okay, so this is 97. This is 86. Okay, 86. And then there is this third side. Okay. So basically he says this is A, this is B, and this is C. Okay, so this is 86, this is 97. Okay, fine. Now with A as center and AB as the radius, meaning the radius is 86. He's drawing a circle, right? So the circle will have a radius as 86. So he'll complete the circle like this. Right? The circle will go something like this, right? It goes something like this. Okay. And so, right, and then let me just complete the circle here. So it'll be something way like this. Okay, are you guys happy with the picture roughly? Yeah, okay. So this is X, this point is X. Moreover, he says BX and CX have integer lengths. So this is 86. So this is integer lengths. So BX is an integer. So let's call this, I typically like, I don't like to use X and Y for non-integers. I'll just use, I would use, so generally the choice of letters is A, B, C and all for integers. These are real numbers, right? For X, Y, Z and all real numbers, A, B, C, P, Q, M, N, K, right? All of these are used for integers. So I don't want to use A, B, C here because capital A, capital B, capital C are here. So the entire side opposite to capital A is what your small a should be. But here, since we have BX and CX, I'll try to use some neutral letters. Like, let me just.
X is in the center of BC.
He didn't say X is in the center of the BC. He didn't say X is the center of the BC. He said BX and CX have integer lengths. That's all. It looks something like center. It's not the center. Right, Yvonne? Okay.
Yeah.
Okay. So let's call this, in fact, we'll give this M. And let's call this N. Okay. So whenever Arav or Aditya, one of you made a good point. Whenever there's a circle with like multiple lines intersecting, and you have a right, you have straight lines intersecting and piercing through the circle, the power rule comes in handy. So what is the power rule? Let's quickly recap. We have done this in the past. Let me use this to draw a circle. So there's a circle tool here. I rarely use this. Okay. So yeah, there you go. And suppose I have two lines here cutting through. So one line here and then one line here. Okay, so the power rule says, so let's say this is A, B, and let's say these points are C and D, just to recap. If the meeting point is P, okay, the power rule says AP into PB equal to CP into PD. So whenever you have two chords CP into PD, when I have two chords intersecting within the circle, AP into PB equal to CP into PD. So you can sort of roughly get an intuition for it. If two of them intersect, there'll be a long part and a short part, or two medium parts. So the product will sort of compensate. So CP is big, but PD is small. And AP and PB are roughly almost equal in length. So you can sort of make sense that it's not a very bad thing, right? AP into PB does look like CP into PD. I mean, it does not look like it, but it's not, right, very off, right? Now, this is fine. But the interesting part is if the intersection happens outside the circle, then also the same thing. So let me just draw a picture for outside the circle. So I'll draw again another ellipse, another circle, sorry. And again, I'll draw the same picture. But this side, this time I'll show the intersection outside. So AB, and then I'll show CD here. Okay, so this is, let's say this is C. The chords were still A, B, and CD. So the two endpoints meeting on the circles are just A, B, and CD. And the intersection point was still the same P. Okay, but still the relation is AP into PB. So you have to go from A to P and then P to B. So AP into PB is CP into PD. This is where people always make a mistake. They write AB into BP. AB into BP equal to CD into DP. That's wrong, right? You always start from A, go to the intersection point. From the intersection point, come back to the other point on the circle. So AP into PB. So the same formula holds good for both this as well as this. Does it make sense? Okay. And also, the extreme case also we have covered. Let's draw another ellipse or circle, sorry. So in the extreme case, suppose I have AB is this chord still. And then you have, let's say C and D are almost colliding to the same point, which means it's like something like this. Okay, so I'll explain this again. So this is your A, this is your B. Okay, now just imagine that C and D, so this is a tangent. So C and D are both the same point. So in this example, you can see there's a gap between C and D, right? Now we can imagine this gap keeps reducing. It literally becomes only 1 point. Let's say C and D become 1 point. So which is why I just put C comma D. Both are the same point. So this point is still P. Again, the same relation holds good. AP into PB equal to CP into PD. Just that in this case, it just so happens that AP into PB is just AP into PB. But CP into PD just becomes CP square, right? We can just call this common point as T for tangent. So it just becomes PT square, right? So you have a square type of thing, right? PT square. Because the 2 points C and D, right, have now collided and just become 1 point. In that extreme case, there is no PC or PD, but it's just a tangent, PT.
How did they collide?
Collide meaning what? If C and D start getting closer and closer to each other, what will happen in final state? Effectively, there'll be only one line and that'll be a tangent, right? Does it make sense, Yuvam?
Oh,
Okay, in general, C, so okay, I'll draw another picture now. So in this case, so let's say C. Okay, so initially C and D were apart, something like this. So the top one was C, the bottom one was D. Now they became closer. Now they became even closer. So finally, they just collided on top of each other. So the C and D, the difference between C and D vanished. Both became the same point. In that extreme situation, it becomes a tangent. Does it make sense, Yuvam? Okay, makes sense to everyone. Sandy, you just joined? I didn't see you better. Turn on the video, please, as feasible.
Oh yes, sir. I just joined. I need 5 minutes.
Okay, no problem. But since you jumped right into the middle of this question, maybe you might not get the full context. I urge you to watch the video later.
Yeah, sir. I'll watch the recording.
Okay, all right, cool. So do all of these three cases make sense? When the intersection happens inside, when the intersection happens outside, and the third one was the intersection happens outside and you have a tangent. So all of these cases are the product of these two parts is the product of another two parts. Right? This is the fundamental. Now let's apply this for this problem now, back to this problem. Okay, now what's happening here? Now the intersection of, what are the chords here? The chords are, BC is a, sorry, BX is a chord that's intersecting outside the circle at point C with which is the other chord. The other chord is sitting here. Other chord is sitting here. This other part of other end of the circle. Okay, let's call this point D or something, right? So this is D. We have not used the word D, right? So D is fine. So the circle is passing through the D like this. Okay, so now, so what am I saying here? So I'm saying the intersection of BX, the chord BX, and the chord DE, these two intersect outside the circle. Okay, where do they intersect? At the point C. You guys agree? So BX is a chord, DE is a chord. Forget about AB for a second. Forget about AX for a second. Just focus on BX and DE. So how do I make you forget this? So maybe I'll just erase this little bit. Thoda. Okay, so let's remember that this length is 86. We'll come back to this. Let's remember this length is 86. We'll come back to this. Okay, so the focus is purely based on the two chords now. Okay. So what was this point? This point was B. Okay, I'll label this point as B. Okay. Are you guys completely with me now on this? Now, A is the center of the circle. A is the center of the circle. And the radius was 86. So this length was 86. And therefore, this balance length was 11. So this length is 11. Are all of you clear so far, please? Anywhere it's not clear, please stop me right away, because otherwise when things accumulate, it becomes even harder, right? So this is 87. This is 11. Except Sanvi, who obviously joined in the middle. So she might. Aditya, you're with me completely?
So how do you get that 11?
86, sorry, not 87. Because the radius is 86. So
Okay.
AB was 86, AX was 86, AE is 86, AD is also 86.
Yes,
They're all radii.
got it.
All of you okay on this? Arav, you're okay? Veer, you're okay? Veer, can you
Yeah.
adjust your monitor position? I want to see your face. I only see you always. Much better, much better. Yes, good. Keep it. You too, maybe. Thoda both. Right, in the normal position, I want to see your full face. Yeah, or maybe you can just over tilt so that even if you bend down, I can still see your face. Okay, all of you good on this, right? So now, let me ask someone. Let's say Veer. Can you tell me a product like how we discussed here in terms of the numbers that we have? We have 86, we have 97, we have 11, we have M, we have N. Can you apply the product rule that we just studied to this problem? Tell me what into what equal to what into what.
So I'm not really sure.
Give it a try, no? Did you understand how the chords intersect and all that?
Sir, can I try?
Yeah, I'll definitely give you a chance. No worries, Yuvam. But one sec, I want Veer to at least start off. Maybe you can do one thing. Veer, you can do one part,
Yeah.
and then Yuvam can
Okay.
complete the right part or whatever, right? So did you understand this? How the two parts product gives the other two parts product, Yuvam, Veer?
To some extent.
Okay. Let's try. I'll give you help. Yeah. Can you start, or should I give it to Veer? Or should I give it to Yuvam, and then you will complete the next part?
I would prefer if we started with you, ma'am.
Okay. All right. Yuvam, give me one part.
Oh, is it BC into XC is equal to DC into AC?
Okay. All right. For first one small thing. So BC into tell the CX. So you're going from B to the intersection point, which is C. And then from C, you're returning back to the other point of the circle. You said BC into XC, which is the same thing. But while telling itself, get into the habit of going from one end of the circle to the intersection point, which is outside. And then from that intersection point to the other end of the circle. So BC into CX. Yeah,
Okay,
agreed? Yuvam?
BC, yeah.
CX.
So
Hold BC into CX, but you're not completing, and you made a small mistake on the right hand side. I want Veer to complete the right hand side. Veer, can you complete this now? BC into CX equal to what into what?
BC into CX is, would it be AD into would it be AD into CA?
I'll write whatever you said. You will just have to explain why. AD into CA. Tell me why. I'm not saying it's right or wrong.
I'm not really sure, but I don't know,
Fine.
instinctively that seems like it makes sense.
Okay, fine. No, it is wrong. Aditya, you want to try?
Yes, so it'll be equal to DC into CE.
Excellent. Yes, I'll write it and then you'll understand it, Veer. So DC into CE. Okay, so same thing happening, right? So there are 4 points which are the ends of the chord. B is a point, X is a point. Just focus on those. D is on the circle, E is on the circle. A will not even come in the picture because A is in the center. Same mistake I think you also did. You talked about A.
Sure, because like I got confused because it was there in the previous one.
Right? So A won't even come in the picture. A is here, right? So the only candidates are D, E, which are on the circle, B and X. These the 2 chords that are formed are intersecting at C. And then now you know from B to C times C to X equal to D to C times C to E. Is this clear? Veer, is this clear to you now?
Yes.
Pakka na?
Absolutely. Yeah.
Okay, all right. Now let's manipulate, but still there are multiple variables. How are we going to solve? Let's see, right? So we have BC. So what is BC? BC is M plus N. BC is M plus N. And what is CX? CX is N. Okay. I'll erase unnecessarily clutter here. So this is clutter, this is clutter, this is clutter. Okay. Just 1 second. My kids are making noise here. 1 second. Sorry. Okay, now, so M plus N into N, that's BC into CX. Now, what is DR, what is DC? Length of DC? Arav. Am I audible? Arav, are you there?
Yes, yes.
Yeah, so what is, complete the right hand side for me. What is DC?
The length of DC.
Yes, length of DC.
So would that be, is that 97 plus 11?
No, not 97. Oh, sorry, maybe the diagram is 97 is from here to here. So DC would be DA.
86 plus 97.
Yeah, 86 plus 86, which is the diameter, plus the 11, correct? Or 97 plus 86,
okay.
right? So what is
Oh,
90?
okay, sir.
Yeah, so 86 plus 86, which is 172, plus the extra 11, which is hanging outside. So that is 183, okay, times CE, which we saw CE was 11, right? Is this clear to everyone? C into 11. Okay, but still there are multiple variables. Multiple variables as in there's both M and N. How are we going to solve? The only advantage right now that we have is these are given to be integers. That's where the integer part comes. So every word is important here, right? So he says these are integers. So which means there'll be the number of choices is far reduced. If it's not integers, then the infinite answers are possible, right? You can always figure out some M and N whose product will be this. Okay, but with integers, the choices will drastically reduce. So let's see. Okay, so obviously, let's try to do some prime factorization and see how these numbers split. 183 is divisible by 3. So it's 3 times, how much is it? 61 times 11 is prime. Okay, so 3 into 61 into 11 is the product of M plus N and N. Okay, so N is obviously a smaller number. M plus N is a bigger number. So how many ways can we split 183? So if you look at 183, so how many factors? How many factors does 183 have? We know, right? It's 3 power 1, 61 power 1, 11 power 1. So therefore, we expect 8 factors, right? In other words, we can write it as 4 combinations: 1 into 183, 3 into 61, 11 into sorry, we are looking at the number 183 times 11, that number, right? So I should say that number 183 times that number, right? 183 times 11. I'm not even going to compute what that number is. It's a big number. 183 times 11 is that 1 into, I'll just call it some n, which is that big number, right? All right, sorry guys, maybe I'm not very clear. So I'm trying to find pairs of numbers, right? I need to find one m plus n and one n, right? So obviously this is a bigger number, right? So my possibilities are this is n and this is n plus m, right? So it can be n can be 1, n plus m can be the 183 times 11, that entire thing, or n can be 3 and this one can be 61 times 11, or n can be 11 and this one can be 61 times 3, which is 183, or n can be 33, 3 times 11, and this can be 61. So this is my n plus m, this is my n plus m, this is my n plus m. Now I just have to analyze all of these few choices, right? Are we clear so far? All of you good so far? Okay. Now here is where the final punchline is, right? So now this, again, this very difficult question only. I'm not denying it. The reason I want to discuss very difficult questions is because even if some parts of this you can take away, you can use it to solve some of simpler problems, right? I don't expect you to solve this question in an exam situation. Obviously, if we do that, that's great. But even if small tidbits of this, let's say the power rule of that, or how to do this integer factorization and take and decide. So all of those small parts, they come in handy in some of the easier questions. So that, and now how to put everything together forms a bigger problem, right? So which is why I want to discuss these.
So
Yeah, Yuvam?
I have one question. Sorry.
Yes, no problem.
N can be like 2, 3 values, because like in the first one, if you take 11, then n can be 11 and n can be 183 minus 11.
Sorry, 183 minus 11?
So basically, it's m plus n is 61 into 3, right?
Yeah,
So which means m plus n is 183.
yeah.
So if you take n as 11, because n needs to be common because it's n plus n squared,
Yeah.
it will be 183 minus 11.
Well, that will be m. I'm not even talking about m right now. I'm just talking about n versus n plus m as a collection, because the product of n and m plus n is what the 183 times 11 is. Sorry, I'm not maybe following your question.
Oh, okay, now.
Okay, I'm not okay. I can have a potential column for m, right? So which is whatever, right? I know n plus m. Therefore, the difference between this and this is your m. I'm not even writing that. I'm just focused on n and n plus m, because the product of these two is what is 183 times 11. Yeah, you're okay. You?
Yeah.
Okay.
So how do we find out the length of BC then?
Correct. So far we agree. So far we are here, right? So now, right? So now let's connect AX here. Okay. Now let's look at that. So now we saw that this is also 86. So we know that AX, BX, sorry, A being the center, AB, AX, AE, AD, all of them are 86, right? All of them are 86. Now let's look at, can n be any of these values? Can n be 1? What does it mean? Can n be 3? What does it mean? Can n be 11? What does it mean? Can n be 33? Right? If n is too small, okay. Now in this triangle A, let's just focus on the triangle AXC. Okay, so I'll just draw that triangle alone separately outside. So A, X, and C, nothing else. Okay, so this is A. This is A. This is X, and this is C. So we know this is 86. We know this is 97. And this XC is my N. All right, I've just drawn that triangle alone separately outside. Now we know that in any triangle, 86, or rather the sum of two sides must exceed the third side. So this problem is brilliant because it's using multiple different concepts. 86 plus N must exceed 97. We have studied this. Sum of two sides is exceeding the third side. Sanvi, more than 5 minutes are up, beta. You should be on by now. Okay. Therefore, N must be greater than 11. The side length N must be greater than 11. And therefore, we can rule out all of these other choices. Therefore, 33 is the only standout. Okay, I'll go through this one more time from the beginning. Don't worry. Therefore, now back to what Yuvam was asking. N plus M is 61. This is 33. Therefore, difference between this and 61 and 23 is my, whatever, 28, I think, right? 28 is my M, right? So we have found everything. Now, what is the question? Find BC. Okay, BC is just N plus M, right? We don't even have to find the 28. So 61 is our final answer, right? Although he has given 28 as a choice in case people do some mistake. He has given 33 as a choice if people do some mistake. 61 is there. 11 is all around. So 11 makes a choice, I don't know why 72. Maybe some other mistake will lead you into 72. I don't know. Okay. So 3 different concepts. Sanvi, your video is on, but I can, similar to you, I'm hardly able to see your face. Tilt down your monitor or whatever, tilt up, whatever, so that I can see your face fully. I'm only seeing the wall. No, further. More. I don't want you to break your monitor. Your mom will start charging me then. Come on, guy. How is it like? For example, I can see Ara very clearly. Yuvam also clearly. Aditya also can see clearly. Can't you do similar? Okay, try. Okay.
Sir, I'll adjust my monitor.
Please do. I'm sorry. Yeah. See, the small things bother me. I need to be able to see all the kids' faces. I'm used to that. Okay. Now, just to recap, multiple things we studied, right? So what are the 3 main things that we studied? One was the power rule. Power rule as in the product of the different chords. The second one was how to do the prime factorization. Not a very big deal, right? It's understanding whenever there's integers, rather the question says something is integer, then the big clue for you is there could be multiple infinite answers if the integer restriction were not there. So if the integer restriction is there, probably you're talking about only a handful of cases to discuss finally and eliminate a few. So which means which will happen through prime factorization and you have to decide. And the third one is the triangle inequality, right? Triangle inequality, meaning the sum of 2 sides in a triangle will exceed the third side. So all of these 3 concepts are being put together. Of course, when you look at the problem, none of this is given to you, right? You have to collate all of this. Difficult question for sure. But my aim is, if I describe this, you should have understood this fully. Can I take that as a yes, Arav? Is this description fully clear?
Yes.
Veer, how about you? Veer.
Yep, sir.
Okay, that's a confident yes or so
Oh
yes?
no, it's confident.
Confident yes. Yeah, please definitely go through the video, guys. Whenever you guys go through it second time, I've been through this multiple times, right? I've told you guys. Definitely it'll sink in better, and try to do this question also once more later. Don't do it immediately tomorrow or something, because you'll remember. I want to remove that bias. Try after 4 days when you've sort of forgotten and you're almost starting from scratch. Are you able to approach it? That's a good test. Okay. Sounds good. So Sanvi might have joined in halfway through this problem, so definitely you should go through it later. Okay, so next one, the only other question, there are 2 other questions left in this, right? Okay, question 10, and then the sphere question, I'll keep it to the last, which is also a hard one. All of these questions that I left towards the end of last class were on the harder side. Okay. In triangle ABC, blah, 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 blah. Sanvi, did you do this question?
Sir, I tried to do it, but I didn't really get it.
Fine. Okay, you tried. That's the main point. You tried hard enough, right? That's good. Anyone with an answer? Aditya, Yuvam? Arav, no? Okay, Veer, how about you?
Just pulling up the answer if I've done it.
Okay. All right. Meanwhile, I'll start drawing a diagram. So ABC.
Yeah, so I've got the answer is B.
B. Okay, nice, wonderful. Let's see. Okay, any other answers? Disagreeing or agreeing with him? Okay, all right. Okay, let's discuss. So this is ABC, triangle ABC. Fine. I might not draw to scale, but it's okay. So he sets medians AD and CE. Okay, so the median is what? From the top vertex to the middle of the opposite side. So this is AD. Okay. And then similarly, this is CE. Just use. So CE would be this. Okay. They're intersecting at blah, blah, blah. What does he say? AD is intersect at P. So this is P. PD is 2. PE is, so this is D, this is E. PD is 2. And PE is 1.5. And DE is 2.5. It's 2.5. Okay, so clearly this does not look to scale, right? It's fine. Always that's what will happen, because unless you fill all the details, you won't know how things are going to land up, right? In geometry problems, unless the question has a diagram, we'll need a second cut for the diagram. And it's okay, even if it's a waste of time, use the learnings from the first diagram to draw a better diagram, because again, you don't need to kill yourself to draw a perfect diagram, but a reasonable diagram, right, should help. For example, with this 2, this does not, compared to this 1.5, this 2 looks bigger, right? I mean, this 2 looks smaller, I mean, when you want it to be bigger. So what I'm going to do is, I'm going to tilt the A more towards C. So I'll draw another diagram right now. It might seem like a waste of time, but definitely it's not. Okay, so this is my BC. Okay, and this is my A. Hopefully this will work, this side. Okay, this is my C. Okay, and I'll draw the diagonals here. Not diagonals, what is it called? Medians. A to D and C to E. Okay, so C to E, so maybe like this. Okay, fine. And then I have DE is also given, right? Let's complete that also. So DE. Okay, so all of these measurements are given. Okay, now let's try to label. This is A, this is B, this is C. And now what are the different lengths that are given to us? PE, so this is P. PE is given to B. This is E, this is P. Sorry guys, my kids are again making noise. Okay. So PE is given to be 1.5. And then now at least it looks reasonable, right? PD is given to be 2. And D is given to be 3.5. Okay. So what is one property of median RF from our initial basics? I'll erase this other diagram so that it's not confusing. Anything, we discussed medians, angle bisectors, and perpendicular bisectors and altitudes. What is a key property of median?
So if it's bisecting the opposite side, it's
that's-
two equal parts.
Yeah, that's the definition of a median. By definition, median is that from a vertex, you go to the center of the opposite side. That's what a median is. But as a result of that, some interesting property of a median. Do you recall?
Oh, so is it the distance between the medium and the other? So for example, E, I'm not sure, E is less than any other point.
Not very clear. Please repeat again what you said. E.
So I'm not fully sure, but there was one about how the distance between the median and the rest of the values is less than it is from any other point.
Not clear discussing anything like this. Anyway, Aditya, what are you saying?
So the medium splits the corresponding side to the vertex in 2 equal parts.
Yeah, that's the definition of a median. That's
And
what I
also like from the center of the median, the centroid of the median, like two meeting points. The median is split into a ratio of 2:1, I think.
Excellent. Yes, exactly. That's exactly what I was looking for, right? So the intersection point of medians. So medians, the three medians, right? They intersect at a point called centroid, which is the center of gravity. So in this case, the centroid is P. Okay, the medians are AD, CE. He has not given the other median, let's say PF or something, right? So if at all I draw just, if I draw the third median, which is not relevant for this problem, right? So I'll just draw it and then I'll erase it. So I'll draw it in light, right? So if the third median will also pass through this. Okay, so PF, say, right? So all three medians will intersect at a center of gravity or centroid, right? And I'll erase this so that, okay. What he's saying is the ratio in which the two parts that each median gets split into will be 2:1, right? The centroid is P, the center of gravity or the centroid. So AP is to PD will be 2:1. Similarly, CP is to PE will also be 2:1. So all of them are 2:1. Similarly, BP is to PF will also be 2:1. Of course, I've not drawn the BP is to PF. I can ignore it. It's not even there in the diagram. Okay, that's a very key important point. So that will straight away give you some lengths. CP is double of PE. Therefore, this is 3. And AP is double of PD. Therefore, this is 4. Okay, so we have a lot of these lengths now. Okay, now that's first observation. Now, the initial question says this is 1.5, this is 2, this is 2.5. Any observation on those numbers, guys? You have any observation on 1.5, 2, and 2.5?
Is it because like the 1.5 is the base, 2 is the height, and 2.5 is the hypotenuse?
What do you mean hypotenuse? How do you know it's a right angle triangle?
So because like the two straight lines crossing each other creates a right angle.
Two medians don't need to cross at right angles. So in fact, if I draw a diagram like this, right? So let's say this is the median and this is the median, right? This does not look like, maybe in this case, it looks more like this, but I can always draw a triangle which looks where it's very obvious it's not a right angle. Let's say this is the median here, right? And this is the median here, right? This angle is clearly obtuse. This angle is clearly acute. Medians do not intersect, do not necessarily have to intersect at right angles. But you are right, in this case, they do make a 90-degree, and that's because why? Arav.
3, 4, 5.
Exactly. If it's 3, 4, 5, you would have recognized. But 1.5, 2, and 2.5 is also 3, 4, 5. It's hidden. Aditya, that's what you were going to say, right? This is 3, 4, 5. The ratio is 3, 4, 5, and which is a very obvious right angle triangle ratio, right? Therefore, this is 90-degree. Okay. And therefore, all of them are 90-degree, right? 90, 90, 90, 90. So 1.5, 2, and 2.5 is a Pythagorean triplet, 3, 4, 5 family. And now what does he want? He wants the area of AEDC, which is like a trapezium, right? This trapezium. So I'm saying it's trapezium because this line is parallel to this line. Why am I saying DE is parallel to CA? Veer, do you know why is DE parallel to CA?
DE would be parallel to CA because
No, DE,
it's
Delhi, DE. Yeah.
DE is parallel to CA because it's like a transversal, right?
Yeah.
There's a transversal of AD cutting across them to form that figure.
But if you know DE and AC are parallel lines, then you can say AD is a transversal.
Oh.
But my question is, why are DE and AC parallel in the first place? Can anyone? Sanvi, why do you think DE and AC are parallel?
So isn't it because the triangle BDE is just a smaller version of triangle AC and they're similar?
Exactly. They're similar. And essentially that's coming from the midpoint theorem. So a lot of things again to connect here. So I'll just draw another side picture here, right? So if I have a triangle here, I'll use some other letter so that they don't bias this, right? So I'd say this is what? I'll just say MN. Oh, sorry. Okay. I'll draw another.
So by any chance is AEDC a trapezium?
AE
AEDC.
is a trapezium. That's what I'm coming to, because ED is parallel to AC, right? But I want to prove AE is parallel to DC, DE is parallel to AC, which is what I was asking Veer. And he said this. I just want to complete his answer a little bit. So let's say I draw a separate diagram here on the side. Let's call this.
Are they parallel?
Okay, let's say this, I'm coming to this. Let's say some other diagram, P, Q, and R. Let's say this is M and N, right? If I have M and N are midpoints of PQ and PR, then by the midpoint theorem, this is parallel to this, and also half of this. Mn is parallel to QR, and Mn is half of QR. Have you guys studied the midpoint theorem in school? If not, I'm sure I would have touched on it. If I have a line segment joining the midpoint of two sides, then that is parallel to the base. The theorem itself says it's parallel to the base, and it's half of the base length. And that comes because you can, as Veer was telling, right, by similarity of triangles. So you can say PM is half of PQ, PN is half of R, and then this angle P is common. Therefore, by SAS property, the small triangle and the big triangle are similar. Right? Does it make sense? Veer, that's what you were trying to allude to, right?
Yes.
Exactly same example here. E and D are centers. E and D are centers of the sides AB and CB, right? And the line connecting D to E, right, will be parallel to the line connecting C to A, and in fact, will be half of that length. So we'll mark that length also. So back to what you were asking, Yuvam, the picture ACDE is now a trapezium, and AC is parallel to ED, right? And we need to find the area of the trapezium. Okay. But having said all that, you don't even need, if you observed as a trapezium, that's great, but he only wants the area of AEDC. And we are lucky that the two diagonals are at right angles. If the moment two diagonals are right angle, it can be any quadrilateral, doesn't matter. It does not have to be a trapezium. If I have a quadrilateral where this diagonal and this diagonal are at 90 degrees, I didn't draw a good picture. Okay, so the area of, okay, I'll just draw another picture. Sorry, guys. So maybe I should do that. Okay, in fact, I'll draw a picture which is not looking like a trapezium. Okay. And this is a diagonal. This is a diagonal. And what should I say? This. I'll cheat. I'll draw this first. Okay. And then I'll complete this triangle. No, not triangle, quadrilateral. Okay. So this quadrilateral that I've drawn is a random quadrilateral, right? It's not a trapezium, it's not a kite, nothing, right? But still, the two diagonals are perpendicular. The moment the diagonals are perpendicular, the area of this becomes half into the product of the two diagonals, half D1, D2. You would have studied this half D1, D2 for a rhombus, right? Rhombus area pata hai na, half D1, D2. It's not just a rhombus. Any quadrilateral where the diagonals are perpendicular, the area is half D1, D2. Why is that? That's because, see, let's say this is D1, but this is half of D1. Sorry, I'm not even saying half of D1. Okay, the entire thing is D1. The entire thing is D2. Let's split into two parts, right? So I'm saying for any quadrilateral, if the diagonals are perpendicular, the area is half D1, D2. I'm proving that. How am I proving? Let's say this part is, let's say P. Okay, this part is Q. And this part is X. And this part is Y. Okay, now, because this is 90, what will the area be? It will be half PY plus half QY plus half QX plus half PX. Okay, because the 4 triangles, in each of these triangles, a right angle triangle. I can take the half outside. Let's combine PY and QY together. So half into Y into P plus Q, right? The PY and QY add up to Y into P plus Q. Sanvi, you're following along? Okay, and the next part, half is outside. QX and PX, I can take X common outside, X into P plus Q. So between these two terms now, P plus Q is common. Therefore, it becomes, I'll write up half into P plus Q into X plus Y. But that is the two diagonals, right? Half into P plus Q was the first diagonal, X plus Y was the other diagonal. So anytime two diagonals in any quadrilateral are at 90 degrees, the area of the quadrilateral is simply half into product of the two diagonals. And the two diagonals are, in our problem, they're intersecting at 90. And therefore, the area, just to complete our problem, is half into D1 into D2. What is first D1? 4 plus 2, which is 6. What is the other diagonal? 1.3 plus 5. Sorry, 1.5 plus 3, just 4.5. So this multiplies to give 13.5. Okay, so well done. Veer, how is this pretty much what you did as well? Although I took a long-winded explanation, I just want to be very clear and complete. Is this pretty much what you did?
Yes, that is.
Okay, well done. Okay, is this clear to everyone? All of you? All good? Okay, Sanvi, you're okay? Okay, the next one is the sphere problem, right? It's a difficult one. I'll paste the sphere problem here. Where is the question? Did anyone do the sphere question? I didn't expect you guys to do, but if you made some partial progress, share till how far you got. Anyone made some partial progress on the sphere question?
I
Yes.
got an answer of B.
You got an answer of B. Wonderful. Okay. All right. I'm not saying B is right, but good that you were able to complete and get some answer. Okay. Anyone else agree or disagree? Okay. Sorry, Arya, I didn't even see you join in the class. Maybe it was not showing up in my window. Has it been a while since you joined?
Yeah, I joined in the middle of question 8.
Oh, okay. Okay. All right. So, okay, this is difficult to describe because it's a diagram, right? So maybe I'll just draw the diagram. I'll just diagram here. Let me just copy paste that, and then you can describe from there. Are you seeing the hexagon? Are you able to see my diagram, guys, with the 6 spheres and the hexagon? Yes or no?
No.
No?
No.
Oh, okay. Oh, it's on this page. Okay, fine. Okay. Okay, I was lazy. I'm not drawing it again here. I'll just paste it here. Okay, so sorry, Arya, before I give it to you, I'll just describe, right? So the 6 spheres, each of radius 1. So these are the 6 spheres, right? This is the top view, right? So it's a 3-dimension. So it looks like a circle from the top. And then there is an encompassing big sphere, which again from the top looks like a big circle, right? So that's the 6 spheres, and the big sphere, which is the 7th sphere, right, are internally tangent to a larger sphere. So let's call this the 7th sphere, right? And then an 8th sphere, right, which in the diagram is difficult to describe. So, but where is it sitting? It's externally tangent to the 6 smaller spheres, right, which means it's symmetric such that it's touching all of those 6. And internally tangent to the larger sphere means what? It's sitting like above all of this, something like this, right? But in the top view, it'll be touching all of those. Are you able to visualize, guys? Are you able to visualize this? From the top, when we view, maybe I should use another different color. So this one, I'll just use maybe a orange color or something, right? So you can see that this is circle. Okay, unfortunately, if I draw this, I won't be able to pull this, right? Oh, I don't know, ditch it. If only I had a tool to show the circle better. Okay, so this is sitting at the top. Okay. In 3-dimension, it's sitting at the top of all of these smaller spheres. In 2-dimension, from the top view, when you look, it look like this. Does it make sense? Okay. Arya, can you go ahead and describe how you got 3 by 2?
So what I did was for the each side of the equilateral triangle, I put it as 1.
Each
I
side of
think.
the equilateral triangle is 1. Is 6 spheres of
Oh wait,
radius
no,
1?
no, no, no. The radius of the sphere of one of the 6 spheres is 1.
Yeah, therefore each of them is 2, right?
Yeah.
Okay. Okay.
And then what happened was, I think, and then I actually drew another diagram from another point of view. So I had the large circle all around it, and then basically I got I was able to draw a diagram between the midpoint of the 8th sphere that was on top and with the tangent. Yeah. I'm not sure how to describe this.
Yeah. I know it's very difficult to describe, right? So even me with a pen here and drawing on this, it's going to be difficult. But that's fine. Let's see whether what you got is right. Even if you didn't get it, I really appreciate the effort. And you got 3 by 2. You got something, at least one of the choices, right? That's good. The effort itself counts. Okay. So let's describe. Let's target this, right? So first, forget the eighth sphere. Let's focus on the 6 small spheres, and the 7th big sphere. Okay, let's try to find the radius of the 7th large sphere, right? So let me just briefly erase this. Just imagine the 8th sphere is not even in the picture right now. Let's say, okay, easier problem for now. Find the radius of the big sphere. Forget about the 8th sphere. Can you guys all take some time? I'll give you 1 or 2 minutes to find the radius of the big sphere. That is easy. I mean, easy as in relatively speaking. Can you try it, please? Except Arya, if you've already done it, just hold off on your answer. I don't want to bias. Okay. Can all of you try to find the radius of the big sphere using what is all given here so far?
Sir, I got it.
Okay, what did you get, Yuvam?
I
As the
got
radius of the big sphere is 6.
yes.
Okay. Okay, now I can clearly say 6 is wrong. Again, not to point a fault. Look at it visually. Does it look like 6? So you have the measurements 1 and 1 here. This is the center, right? If I have to take an intelligent guess, it's maybe looking 2.5 to 3 times this, right? This is center. Let's say this is the center O. And I have the lengths 1 marked here. So it doesn't look like 6 times, no, visually. And it's reasonably to scale diagram. In fact, perfectly to scale diagram. You have 6 circles, hexagon, big circle. Do you agree with me, Yuvam, that the radius of the big circle does not look 6 times?
Sir,
Or did you mean the diameter?
oh yeah, sorry, that's the diameter. The radius is 3.
Okay. All right. That seems more reasonable. How did he arrive at 3?
So see, so is this an equilateral triangle? Sorry
Yes,
for the
that
bad
no,
handwriting.
please. That's fine. That's an equilateral triangle. Yes.
So we know that the radius of this is 1 because
Radius
from
of the
this
small
to
circle is
this,
given to be 1. Yes.
yeah, so this is 1. So even like this to this will be 1.
Yes. Excellent. Very good. Yes.
So then it's 2 plus 2 plus 2. So if this is 2, the length of this side, then even this will be 2.
Correct. Yes. Correct.
Even like this will be 2.
Agreed. Okay, perfect. Okay, so just so that like everyone is on the same page, well done. So this is 1. So this is 1. And we are talking about all equilateral triangles here. Okay, so each of the equilateral triangles, the side length is 2. And therefore, this has to be 1. This has to be 1. Right? And the radius of these circles is 1. So if I extend this, this will be 1. Therefore, the radius of the big circle, capital R, is 3. Okay, so let's call the radius of the capital 1 is 3. All of you clear on this one, right? Fairly simple. The 3 parts, 1, 1, and 1, right? The diameter of the small circle plus an additional 1 here because this triangle has side length of 2, 2, and 2. All of you agree with me, Sanvi? You're in agreement with me that the radius of the big circle is 3. Sanvi, you grayed out this thing. I can see a very murky picture of you now. Or Sanvi, are you with me? Sanvi? Hello? Did we lose her? Okay, all right, whatever. Okay, so Sanvi, if you're hearing me, just adjust your video, whatever. I can barely see you. It's very murky picture. Okay, so the radius of the big circle is 3. Well done. Okay, now comes the 6th. Sorry, now comes the 8th wala sphere. Now we have to visualize in the 3-dimensional picture. So what's happening here in the 3-dimensional picture? Now, how will I show this? Just imagine. Okay, now I'm looking at it from, this is the top view. This is the top view. Now look at it from the side view or the front view. Okay, so I'm just drawing a front view. Okay, so from front view, how is it going to look like? Again, it will be the same big circle. Okay, so let me just draw a circle. Tools, circle. Okay, so this big circle will be here. Okay, now I'm looking in from the front. Okay, now these, I won't draw all the small circles. I'll just draw one of the small circles. So one of the small circles will look something like, I don't know how to draw this circle now with this. It's bigger than this though.
So is the 8th circle over, like it's
Yes.
above, is like under the large
Yes. Yeah.
circle?
So the 6 circles, the 6 small spheres are all on a plane. Let's say they're all in a hexagon shape. The 8th circle is encompassing all of that like a big dome, right? Now, above all of those 6 spheres, in that gap, is sitting, the 8th sphere is sitting, such that from the top, it's touching the big sphere. So which is why it's internally tangent to the big sphere and externally tangent to the 6 small spheres. Is this clear?
So it just be like just under the larger sphere, right?
Yeah, correct. Right? So on top of all, so wait, if I draw a diagram here now, you'll understand, right? So let me just.
So shouldn't the radius of the 8th circle also be 3?
1 second, I'll just. So this is radius of 1, right? So I'm looking at it from front. So from front, when I look, there are 6 spheres, right? So they're all going to be in this band. So all of those 6 spheres are in this band. Okay. Okay. So all of those 6 spheres are in this band. Are you guys with me so far? This is the master center of the entire sphere, and essentially this point O. Okay, all of the, I'm not drawing the other 6 small spheres because it will confuse you. Okay. Yuvam, just bear with me for a second and then I'll answer. Now from the front, this should be clear. The 6th sphere is, I keep saying 6th, it's the 8th. The 8th one is sitting above like this. Right? And imagine there are 6 blues, but I'm not drawing all the other blues because it will confuse you. But does this picture make sense? This is the front view. This is the front view. In the top view, if you look, it look like this. In the top view, if you look, the 8th sphere is looking like this. In the top view, the 8th sphere is like this. Sanvi, are you able to visualize this picture, Sanvi? Visualization is something
Yeah.
that each person has to feel it, right? You're okay? Good.
Yes.
Arya, you did the problem. That's good. Veer, Arav, Aditya. Okay, right? Yuvam, you're okay with the 3D diagram?
How is this internally tangent to the larger sphere?
Because it's, what is internally
It's
tangent?
not tangent.
It is, no, it is inside. Tangent means, okay, forget 3 dimension. What is internally tangent in 2 dimension? What is externally tangent in 2 dimension? So this circle and this circle are externally tangent, right? Whereas this circle and this circle are internally tangent, correct? That's what internally versus externally means, right? Tangent. Does it make sense, Yuvam?
So I have a question.
Yeah, no, before you go to you, Yuvam, is this clear? The concept of internally tangent means what? It's still tangential, but the tangentialness is internal. The circles are touching each other internally, or rather one circle is within the bigger circle. Yuvam, what's confusing about this?
So because like the 8th circle is not touching the larger circle.
It is, no? Where? It is given to be, and even in a diagram, it is touching, right? Where is it not touching? In the top view. In the top view, obviously, it won't
Yeah.
be touching, right? In the top view, how can it describe? Because look at you have to connect both the top view and the front view. In the top view, it's sitting above all of these 6 spheres. And then the black big sphere will be touching it at the top, which is why I need you to see the front view. In the front view, you can see that it's sitting at the top. Are you able to imagine? This is the top view. This is the helicopter view. From the helicopter, you're viewing this. And this is from the front, you're viewing this. It's called front view. Spend some time on visualization, Yuvam. This should be easy. Okay, but internally and externally tangent, you should understand, right? What is internally, what is externally tangent? Okay, Aditya, your question, please.
So I got it.
Okay, please, can you repeat the question? Maybe someone else had the same question.
It was the same as you, that why it's pure touching in the top view.
Very good. But you're convinced now, Aditya?
Yes, sir.
Okay, good. Yuvam, don't take me wrong. If you spend some time, you'll understand, right? Just imagine how the top view will look like. You're looking at it from the helicopter. How will it look like? Because the sphere will be all the spheres will be crushed into a circle. You won't be able to see the height difference at all, which is why you're not seeing that this is touching, right? But actually touch ho raha hai. This pink circle ka upper portion is actually touching the black circle ka upper portion, and that's happening internally. And I'm able to show that in the front view. This is where the touching happens. Okay, so you spend some time more on visualizing this. I'm sure you'll get it. Okay, now with the front view, how is this better? How are we able to solve this now? Let's see. Now, again, whenever circles or spheres are touching, the first thing you should do is connect the centers. So this is the center of the 8th pink sphere. Okay, so I'll connect this with this. Okay, and then the small sphere and the big sphere centers I'm connecting. And then the 7th and the 8th sphere, the big sphere and the pink sphere I'm connecting. All of them I'm connecting because everything is tangent to each other. The 6, so the representative of the 6 blue spheres is one of them. I've just drawn one of those 6 blue spheres. There's only one pink sphere. There's only one big red sphere, right? Each of them is touching each other. I've drawn the lines connecting each of those centers. Is this clear? Now, what all do I know? I know the dimensions of the small sphere, right? The small sphere radius is 1. So I'll mark that as 1. So this is 1, right? And I also know that the radius of the big sphere is 3, right? Which means this is radius of the big sphere is 3, right? So why did I say this? Okay, yeah, it's one. This is 1. No, this is 2 or 1. No, this is 2. No, so what I drew here was it's 2 or 1. I'm just getting confused myself here. This is okay. This is 1, but this radius of the big sphere is 3. Okay, so this is 3 minus 1, which is 2. Okay, so let's say this is O. Okay, let's say this is P, and this is Q. Okay, so this let's say this is some other point n. So Pn is my 1. Okay, now let's say this is, I don't want to confuse too many points. All I'm saying is this is 1. What is OP? O to P would be sorry. Okay, I made a mistake. This is not 2, right? Sorry, guys.
Sir, now I got it.
You got it? Excellent. Okay. But I really like that you didn't admit that you got it. You did not pretend to get it. So that's very good. Okay. All right. Now OQ is what? It's 3 minus R. Okay. Where R is the radius of the pink sphere. R is the radius of the pink sphere that I'm trying to find out. R is the radius of the pink sphere. Okay. Now, why am I saying this OQ is 3 minus R? OQ is 3 minus R because O to the top is 3. And then I'm subtracting this radius, which is R. So this is R. Therefore, OQ is 3 minus R. Okay. What is OP? OQ is 3 minus R. Okay. And in fact, let's do what is OP. Okay, let's do QP. Okay, QP is R plus 1. Right? QP is R plus 1, right? The radius of the pink sphere and the radius of the small blue sphere. Okay, now that leaves us just with OP, which is easy. OP is your 3 minus 1, which is 2. Right? This is 1, this is 1, this is entire thing is 1. Therefore, this OP is 2. Are all of us in agreement with these dimensions here? Right? Okay, so now it's just Pythagorean theorem, Pythagoras theorem and setting it up, right? So OP square, so 2 square plus 3 minus R whole square equal to R plus 1 whole square. Okay, so this is 4, this is 6 minus 6, sorry, 9 minus 6R plus R square. It's not even a quadratic right now because the R square will get cancelled. R square plus 2R plus 1. R square gets cancelled, 8R, and I'll take the 1 to the left hand side. How much is it? 12. Excellent, Arya. It is indeed 12 by 8, which is 3 by 2. Sorry, say that again.
So how did you get 3? How did you get 3?
3 for which one? 3 minus R, you mean?
Yeah.
The radius of the big sphere we already established was 3. That was the first thing we did. You only said it's 3. Remember, radius of the big sphere is 3.
Oh, yeah.
Correct. And therefore, O to the top, let's say the top is point T or something. OT is 3. And then I'm subtracting R here. Therefore, this gap becomes 3 minus R.
Oh, correct.
Right? And now it's just Pythagoras theorem. Is this clear, guys? Definitely a difficult question. Again, the reason for doing this is the learnings from this can be used in a simpler problem. A simpler problem you'll be able to easily attack now. Even if this problem you won't be able to attack. Right? Does it make sense, guys? Okay. All right. So are we done with this homework fully? Okay, we're done with this homework fully. So what I'll do is, in fact, I wanted to discuss, I'd given a test last year, like just a miscellaneous test on all the problems discussed so far. I'll give the same test rather than, because we trying to finish like 10 minutes early. We started at 6:25. I wanted to go for another 8 minutes, but it's fine. We can end a little early here. I'll send you as homework the test that I gave last year for the last year students. and you can try it as a homework. It's a miscellaneous topic so far, right? And then we'll discuss the test during class, right? So I'll just show you, no, not show you, I'll just send you, but please stick to the timelines and just simulate yourself as if you're writing a test. It's a simpler version, not simpler version, shorter version than the real test, but only few questions, but you have to actually do all of those questions in the set limit of time. Okay, that'll be the homework for this time. Okay, before we wind up, any specific questions, guys? All okay? Okay, cool. I'll let you go a little early today. Okay, chalo, bye. See you.